let us learn now properties of numbers. One of the properties is closure property. So to understand the closure property, let us go first of all with natural numbers. So what you do, natural numbers, I think you know, all counting numbers are called natural numbers. Now what you do, close these all numbers in a bag. So means keep all these numbers in a bag. Imagine that you have kept all these numbers in a bag and closed the bag. Now imagine any two numbers from this and add them. I am taking two numbers 5 and 7. I am adding them. 5 plus 7. 5 plus 7 is 12. Is 12 again a natural number? Yes, right? So 12 will be in the set of closed your bag. In your closed bag there will be 12 in that. Right? So thus if you add 5 plus 7 you got 12. You take another two numbers. 1 comma 10. Add them. 1 plus 10 is equal to 11. Thus not only these numbers, you take any two numbers and add them. Do you get again a natural number? Yes, right? That is why we say natural numbers are closed under addition. Natural numbers are closed under addition. Means sum of any two natural numbers again a natural number. So you can say for all a comma b belongs to n, means for each and every natural number, for all natural, this symbol stands for all belongs to, means for all a comma b, or else for each and every a and b in natural numbers, a plus b also belongs to natural numbers, right? That is why natural numbers are closed under addition, right? Or natural numbers satisfy closure property under addition, right? If you are able to, even if I give 100 examples to say it is true, if you are able to give a single example to give, it won't satisfy. So then we hear that natural numbers are not closed. But can we give such an example? Not possible here in case of addition, right? So now if you take subtraction, let us take subtraction. Let us take two numbers again, 5 comma 7. Now what I am doing is I am doing 7 minus 5. I have taken two numbers. I did 7 minus 5 is equal to 2. I am thinking that I have taken two numbers, I have subtracted, again I got 2. So that is why natural numbers are closed under subtraction. I may consider, because I am not good at subtraction. So 10 minus 6 is equal to, again if you take 10 comma 6, 10 minus 6 how much? 4. Again 4 belongs to natural numbers. You take 9 and 4. What is again 9 minus 4? I am thinking that on subtracting any two natural numbers, again I am getting a natural number. I am thinking like that, right? If I am not good at, so some other person who is intelligent may say, what if I subtract 5 minus 7? 5 minus 7. So here students will generally confuse here itself. So you learned this type of subtractions, big number minus small number, up to 5th class. This type of subtraction, big number minus small number, will come from 6th class. How do you do such subtractions, right? You imagine, like, so big number minus small number, right? Subtraction means removing, right? 5 minus 7, right? So consider that you have 7 anything, pens or pencils. If you give 5, again you will have 2, isn't it? So that is what plus 2. If you have 10 pencils or 10 chocolates, you can give 6 to anyone. Remove, subtraction means removing. So you can remove, or simply you can remove from 10, you can remove 6. From 10 you can remove 6, remaining will be 4. From 9 you can remove 4, you can remaining 5. But if you have 5, how can you remove 7? You have 10 things, but you have to remove 7 things. So then go for, instead of plus 2, give minus 2. Right? So in other way, remember, small number minus big number is minus 2. So now 5 and 7 belongs to natural numbers. 5 minus 7 is minus 2. Does not belong to natural numbers. It is not in the set of natural numbers. So natural numbers are not closed under subtraction. Therefore, natural numbers are not closed under subtraction. In another way, you can say, for all a comma b belongs to natural numbers. For each and every a comma b in natural numbers, a minus b need not be a natural number. Right? A minus b may not be a natural number. So natural numbers are not closed under subtraction. Right? Now what about multiplication? Right? Multiplication. Multiply. Again, take any two natural numbers, 5 and 7. Multiply them. 5 into 7, how much? 35. Right? Is 35 a natural number? Yes. 5 comma 5 and 7 are natural numbers. 35 is also a natural number. 1 comma 3. 1 into 3 is again 3. Natural numbers. 7 into 11. 7 11s 77. Again natural number. Right? So 35 belongs to natural numbers, 3 belongs to natural numbers, 77 belongs to natural numbers, 7 comma 11 belongs to also natural numbers. So you take any two numbers, natural numbers, and multiply them. Again you will get the product. So when you multiply two numbers, whatever you get, that is called a product, and these two are called factors. Now the product of any two natural numbers is again a natural number. So we say natural numbers are closed under natural numbers are closed. Can you give at least one example that to say that product of any two numbers is not not a natural number? We can't. That is why natural numbers are closed under multiplication. Now what about division? Right? Let us keep this statement. Right? Now take 14 comma 7. Divide 14 divided by 7. 14 by 7 is equal to 2. Right? 7 ones, 7 twos, 2. So 2 is a natural number. 14 and 7 are natural numbers. And on division I got 2. 2 also a natural number. 2 belongs to a set of natural numbers. Right? Now, what about if I do 7 divided by 14? You have to do like this. 7 divided by 14 means 7 in numerator, 14 in denominator. So 7 by 14 is half. 7 ones, 7 twos. Half is not in the set of natural numbers. Right? They are all full numbers, counting numbers. We use 1, 2, 3, 4, 5 only. Right? There are no parts in set of natural numbers. So 7 and 14 belongs to natural numbers, but 7 by 14, quotient of them, when you divide them, the quotient may not be in the set of, whatever you get on dividing 7 by 4 may not be in natural number. Sometimes it will be, sometimes it will not. But that is what, it is not always true, right? It is not always possible to have the number that we get after division in set of natural numbers. That is why we say natural numbers are not closed under division, right? So if you write in a table addition, subtraction, multiplication, division, right? Which property? Closure property. Addition, yes, for natural numbers. Subtraction, no. Multiplication, yes. Division, no. Right? Closure property for natural numbers. Right? Similarly, we can find out whether whole numbers and integers are whether closed under addition, subtraction, multiplication and division. So very simple. So you continue same like that. Take any two whole numbers and add them. 0 plus 1, again one whole number. 1 plus 3, 4, again a whole number. Right? So there are no negative numbers in the set of whole numbers. Whole numbers contains only 0 extra compared to natural numbers. So on adding any two, add any two numbers, 3 plus 4 is equal to 7, belongs to again whole numbers. 0 plus 4 is equal to 4, belongs to whole numbers, right? So that is what students even confuse here. 0 plus 4, 0 means nothing, nothing plus 4 is 4, right? So on adding any two whole numbers, again we get a whole number. So whole numbers are closed under addition, right? Whole numbers are closed under addition. What about subtraction? Like natural numbers, if you do a small number minus big number, 2 minus 3 is equal to minus 1, does not belong to whole numbers. So whole numbers are not closed under subtraction. Take any two whole numbers and multiply. 0 into 7 is equal to 0. 0 times any number is 0. So 0 again a whole number. 7 into 5 is equal to 35. Again a whole number. Can you give at least one example to say that product of any two whole numbers again is not a whole number? Product of any two whole numbers is not a whole number. Can you give an example like that? It is not possible because product of any two whole numbers is again a whole number. That is why whole numbers are closed under multiplication. What about division? So same number you take again, 7, whether 7 by 5 or 0 by 7 by 5 or 5 by 7, 2 by 4, these numbers 7 comma 5 are whole numbers, but 7 by 5 is not a whole number. 5 and 7 are whole numbers, 5 by 7 is not a whole number. So on dividing two numbers, you may not get the quotient again a whole number. So that is why whole numbers are not closed under division. Integers. So integers contain along with the whole numbers, negative numbers it contains. Now add any two numbers, minus 3 plus minus 2 is equal to. Students again here confused. Addition means together, clubbing together. So starts confusion again here. So you think here 3 plus 4 means you have 3 rupees, 4 rupees. Together you will have 7 rupees. So minus 3 you consider as borrow. You have a borrow of 3 rupees. All negative numbers consider as borrow. You have a borrow of 3 rupees. You have a borrow of 2 rupees. Together how much? Together will be a borrow of 5 rupees. So minus 5. If you have a borrow of 5 rupees and if you have 9 rupees with you, what you can do? You have a borrow of 5 rupees and plus 9 means you have 9 rupees with you. You can clear your borrow 5 rupees. So from this minus 5, sorry, for this minus 5 plus 5 gets cancelled, means you have cleared the borrow. From 9 you can plus 5 you can give to clear the borrow, then you will remain with 4. Now take 5 plus minus 9, means you have 5 rupees but you have a borrow of 9 rupees. You have 5 rupees, you have a borrow of 9 rupees. If you clear that borrow, sorry, you have 5 rupees now. If you clear 5 rupees, again you will have a borrow of 4 rupees, right? You have to give again 4 rupees. So minus 4. Right? So you think like that. So in order to remove the confusion. Right? So observe here. Addition of any two integers is again an integer. So integers are closed under addition. What about subtraction now? So you know already, if you take two numbers like 3 minus 2 is again what? 3 minus 2, big number minus small number. You have 3 rupees, you can remove two numbers, you can give two numbers, so you will remain with 1. If you do like this, 2 minus 3, big small number minus big number, means you have 2 rupees, subtract, remove 3. If you have 2 rupees, how can you remove 3? So right here, minus, reverse for this. 3 minus 2, you have learnt up to 5th class, 2 minus 3, right? Minus. Now, 2 minus of minus 3. Minus of minus, remember, minus of minus is plus. So it becomes 2 plus 3. 2 plus 3 is equal to 5. 5 is again an integer. Again an integer. So, in this way, if you subtract any two integers, again you will get an integer. Right? We can't give even a single example to disprove this, that subtraction of any two integers is not an integer. For proving that, we cannot give even one single example. That is why on subtracting any two integers, again you will get integer. So integers are closed under subtraction. Right? Integers are closed under subtraction. What about multiplication? Multiplication you have seen in natural numbers and whole numbers, it is true. So it is true in integers also. So you can remember blindly, addition and addition. Addition is true for all, multiplication is true for all whole numbers, natural numbers and integers. Subtraction only for integers, no for whole numbers and natural numbers. So now multiplication. Take any two numbers, minus 3 times 5, or else 5 times minus 3. 5 times minus 3 is minus 15, right? So plus into minus is minus, right? Plus into minus is minus, so minus 15. Minus 3 times minus 5 is equal to plus 15. So product of any two integers is again an integer. So whole numbers are closed under, integers are closed under multiplication. Integers are closed under multiplication. Right? What about division? Minus 3 by minus 2, 4 by minus 7. No numbers belongs to integers. These numbers won't belong to integers. Minus 3, minus 2 are integers. 4 comma minus 7 are integers. But minus 3 by minus 2, 4 by minus 7, division of them, quotient of them is not integer. So integers are not closed under division. Right? So this you have to remember.